So I wanted to just have a look at the reciprocal function for cosine, which is sometimes called secant of x or sec of x. It's basically just 1 over your cosine of x values. So let's just review our cosine of x values around our unit circle, or we can look at this graph here to get our values right. So just a quick recap, cosine of 0 is 1, because when we have 0 radians or 0 degrees, we're up here at 1. Cosine of pi on 6. Okay, let's look at our triangles here. Pi on 6 is 30 degrees. We're standing at 30 degrees. Cosine of some angle is equal to the adjacent side over hypotenuse. So that's going to be root 3 on 2. Okay, this one here is going to be 1 on root 2. This one's going to be 1/2. Cosine of 90 degrees is 1. No, it's not. It's 0. Cosine of 90 degrees is 0. Cosine of pi is -1. That's one that students can get confused. The next one at 3 pi on 2 is back to 0. And then 2 pi, we're back at 1 again. Okay, and all of that matches up with our cosine graph. So if we look at this cosine graph up here, all of those points should match up. For example, at 3 pi on 2, its cosine value of 3 pi on 2 radians is 0. So what we want to do next is we want to think about the secant function, which is 1 over cosine x. So basically for the first one, all we're going to do is going to take 1 divided by whatever number's in this row. So 1 divided by 1 is nice and easy, is 1. Okay, next one, 1 divided by root 3 on 2. So that's 1 divided by root 3 on 2, which is 1 multiplied by 2 on root 3. Okay, so the effect of doing the reciprocal is to just flip the fraction. So this just becomes 2 on root 3. Okay, again, flipping the fraction, this is just going to become root 2. This one's going to become 2. All right, next one, 1 divided by 0. Well, 1 divided by 0 is actually undefined. You can't divide by 0. Next one, 1 divided by -1. Well, that's just -1. 1 divided by 0 is undefined. And 1 divided by 1 is 1. So that hopefully checks out. Essentially all we're doing now is we're going to plot our radians on the x-axis and then plot the secant values on the y-axis. And we're going to start to think about what that might look like. One thing we can start to think about is that we've got these interesting points, these undefined points. So when x is pi on 2, we know that secant is undefined. So that must mean we actually have an asymptote at that point there. And it also must mean we have an asymptote at 3 pi on 2. As you can see at 3 pi on 2, it's also undefined. The same logic would apply at -pi on 2 and at -3 pi on 2. So we're starting to get a feel for where the secant of x will be undefined. We can also look at some other interesting points. Let's look at cosine or secant of 0 degrees. That's actually equal to 1. So we're actually going to be at this point here. Okay. And then let's look at another point, 30 degrees or pi on 6. That's going to be, just to the right, 30 degrees. That's going to be around here somewhere. It's going to be symmetrical. I'm going to show you exactly what it looks like in a moment, but you can maybe start to see it's going to look something like this. Okay, let's have a look at what the graph actually looks like and then we'll talk about it in more detail. So we can sort of start to see that we have this situation here where we've got these asymptotes. Now these asymptotes, as we said, are going to be x equals pi on 2, x equals 3 pi on 2, and it's symmetrical, so x equals -pi on 2, and x equals -3 pi on 2. Okay, so let's define this function. Let's call this function f of x equals secant of x. Okay, now what we want to do is we want to think about the domain of this, and it's actually not that straightforward. So let's put our thinking caps on. So the domain of this seems to be all real numbers. We can take on any x values except where x equals pi on 2, 3 pi on 2. You can probably start to think at 5 pi on 2, 7 pi on 2, 9 pi on 2, 11 pi on 2. You're going to have these asymptotes. So what we can actually say is the following, and this is where it gets a bit tricky. We're going to say that the domain is all real numbers, not including, any odd multiples of pi on 2. So how in maths do we talk about an odd number? Well, if I say 2n plus 1, if I take where n is any integer, n is an integer, then 2n plus 1 is odd. And we can think about that for a second. If I pick any number, let's pick the number 3, let's say n equals 3. Let's substitute it into 2n plus 1. It's going to be 2 times 3 plus 1 gives us an odd number. That gives us 7. So 2n plus 1, where n is any integer, is going to give us an odd number. So we're going to say all the real numbers except any odd multiples. So 2n plus 1 pi on 2, where n is an element of z. Now z is any integer. Z is the set of all integers. That's including positive and negative numbers. So that's the set. Let's just be clear. Z, capital Z, is this set, dot, 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 and then we got, -2, -1, 0, 1, 2, and so on to infinity. So that's actually our domain of our secant function. Real numbers, not including any odd multiples of pi on 2. Okay, the next thing we might want to think about is the range. So let me just separate this. So the range, maybe you can see from the graph, is going to be, it goes down to negative infinity and it goes up to positive infinity, but there's certain values of the range that we can't have. And we said before that this point here is at 0, 1. And I can tell you that this point here, and you can crunch the numbers, but is at pi, -1. Okay, so you can see that we can take on any values in the y direction except values between -1 and +1. So let's write that down. So we're going to take, the range can be all real numbers, not including, now it can, this is where it gets a bit confusing. I'm going to use round brackets because on the graph of secant of x, the point 1 is defined. So I'm excluding everything up to 1, but not including 1. So I'm excluding all of those values because 1 can be included. So the range is going to be all real numbers, not including -1 to 1, where this is an interval, right? This is an interval between -1, interval from -1 to 1. Hopefully that clarifies things a little bit. Yeah, I think a table of values really helps because all you have to do is you really just need to substitute in your cosine values. Your exact values, and you take 1 over those values, and then this is what pops out as the result. And then you just have to have a think about the domain and range. So hopefully you found that useful.